Hi, we're going to be looking at the area of a parallelogram. So just like we did with the area of a rectangle, anytime you're measuring the area of a flat surface, you want to count the number of squares on that flat surface. We run into a problem though with our parallelogram. If you can look here, these aren't complete squares. Now remember that a parallelogram has four sides where your base and your top are the same length and your two sides are the same length. It looks like a rectangle that got pushed over on its side. So one thing to remember is anytime you're measuring the area of any shape, you want to see if you can turn it into a rectangle. If you remember, the area of a rectangle was the base times the height. Here's the base on the parallelogram. This is not the height. That's a side. The height of your parallelogram is measured from your vertex up and down. It could be on the other side as well, from the vertex straight down. So what we want to do is see, can we turn this parallelogram into a rectangle? And we can. Now if we look at this new transformation, we can see exactly what happened. Now if we start here, I'm going to take it back to my parallelogram. We can count the number of complete squares on the base. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Even though this isn't a complete square, we're just looking at the base, and that is a complete base of a square. So we have 10 as the number on our base. Now we're going to look at our height and count how many squares make up the height. 1, 2, 3, 4, and 5. 5 is the height. When I transform my parallelogram into my rectangle, I want to see what changed. Well, my height, 1, 2, 3, 4, 5. Well, my height didn't change any. It's still 5. Let's count the base. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, my base didn't change either. So now I know that the formula for a parallelogram for the area is exactly the same as the formula for the area of a rectangle. Area equals the base times the height. And if we transform it back, you'll know that you'll just count the number of squares along the base, the number of squares on the height, and you just multiply. And just like with area of a rectangle, your work will now be to draw your own. There are a few tricks to drawing your own parallelogram that I would like to show you. So you get out your piece of paper, and just like all of our work, you need to put your name on the top and give it a title. Oh, I made a mistake. I make a lot of those. Parallelogram. That is a very tricky word to spell. So when you are doing your area of a parallelogram, the first thing that you want to do is make your base. Let's say I would like this base to be 6. I count over 6 squares. 1, 2, 3, 4, 5, 6. Now, what I want to do is come over a couple of squares and then count up from my height. I'll make my height 3. So I go 1, 2, 3. Now, if my base is 6, this must also be 6. 1, 2, 3, 4, 5, and 6. And now I'll just connect my dots using a straight edge every time. Don't try to freehand. And here is my parallelogram. When I draw my height on the parallelogram, I like to use dotted lines to really highlight. Now I could say that this is my height, but I could also say this is the height as well. This is not the height. So now I just need to label. 1, 2, 3, 4, 5, 6. 1, 2, 3. Just like I do with the rectangle, area equals base times height every time. Now I substitute my numbers. My number for base is 6. My number for height is 3. And 6 times 3 is 18 squares. Circle the answer. So your job would be to do lots and lots of problems like this with lots of different numbers. If you'd like to cut them out and make them movable, you certainly may. You may just leave them on the paper here if you like. And that is the area of a parallelogram.